Now we're going to look at the Lab 4-6, which I'm going to consider Part B to Lesson 3, Manage File and Directory Permissions. Okay, so here we're going to manage file and directory permissions. This is our topology. Here are our instructions. When a user logs into a Linux system, a new shell process starts, which runs with the user's user and group IDs. Each user account has permissions that can access only certain files and the files the user creates. The user cannot access files that either belong to other users or that are system files. The application that a user starts, it inherits the user ID and therefore has access only to the files and objects on which the user has access. Any object on which the user does not have access, the application which the user is running does not have access. Okay, in this exercise, we're going to manage file and directory permissions. We'll log into the Linux system, set access modes, and work with immutable files, meaning we can't change them. Okay, we're working on the CentOS server, which is PLAB Linux 01. So I'm going to come up here and make sure it is turned on. And I'll click on it to make that the active window, and here I can watch it boot up. Okay, permissions in Linux has two special modes, SUID, which sets the user ID, and SGID, which sets the group ID. When an executable program has the SUID mode set, it will run as if it had been started by the file's owner rather than by the user who really started it. Similarly, the SGID access mode sets the program will run as if the initiating user belonged to the file's group rather than to his own group. Either or both access modes may be set. And this task will set the access modes. So on the computer, right click and open terminal. And step 2, we're going to list the SUID access mode. So I'll type ls-l/USR for user /bin/pass PASSWD. Notice that the user permission does not contain the execute permission, rather there is an S, which indicates that the SUID and executable bits are defined for this file. When a user needs to run PASSWD, it executes as if the root user has executed it. You can set the SUID and SGID bits. This is done by adding the S. SUID has the value 4 and SGID has the value 2. Any directory that has SGID mode enabled, all files and subdirectories will inherit the group ID of the directory. So let's first create the directory by typing mkdir plab. And then we'll assign SGID with chmod space G plus WS space plab. Okay, we'll clear the screen and then ls space dash ld plab. And that lets us view the assigned SGID. Clear the screen and we'll create a file. Touch plab /test.txt. Clear the screen. Not sure why they have us do that so many times, but it is a good standard to get into so you don't confuse yourself, but a lot of people like to see what they just typed. And so we list it again for the file. And we can see the permissions for the newly created file. We want to remove the write permissions for the group. So chmod G space or G dash W. Oh man. Space plab /test.txt. And I'm not test.txt. There we go. Okay, so we did do that one, and they want us to clear the screen and change the sticky bit. Chmod plus T for plab. Come on, pay attention. Plus T for plab. Each of the access modes is represented by symbolic and octal values. S with U, octal 4000, S with G 2000, and sticky, which is T, is 1000. To print the symbolic and octal values, we would type find space dot space dash name space plab space dash space printf quote percent uppercase M space percent lowercase m space percent f /n, end quote. Right, so okay, so I think I typed something wrong in there and I took the space out on printf and retyped that line, and I still got a permission denied, which is not what it says I should have here. So if yours is looking like this, you're seeing what they see, and I'm somewhat seeing the same thing. My permissions are a little bit different. Yeah, they're on the administrator. That's what I was looking for there, see if we're on the same account. But yeah, it is. I'm not sure why the permissions came out different. Maybe they had set one of theirs or not set one of theirs before they did this particular thing. Right. Test 2, even though access modes and permissions provide great control over files and directories, however, they cannot prevent the accidental deletion of files by the root user. You can set the immutable attribute on files and directories. When this attribute is set, even the root user cannot delete these files and folders. Okay, so first I'm going to clear my screen, get rid of what we were working on, and go to root user, SU, passwords, uppercase PASSW0RD, and I get logged in to the root user. Okay, we'll create a file using touchplab.txt. Need to set the file's immutable attribute. Me and my scroller are not getting along. To do that, we type CHATTR plus I and the name of the file, plab.txt. Now we need to verify that attribute has been set, so we'll list the attributes, lsattr, plab.txt. And you see immutable, or the I. Clear the screen, and we'll attempt to delete the file rm-f plab.txt, and it says, nope, you can't do that. Now to remove the immutable CHATTR minus I to the name of the file, plab.txt. Okay, and I'll relist the attributes. You see the I is not there. Now we'll again attempt to delete the file. And I did not get an error. That means it deleted the file. We can list files there and see that plab is still there. No, plab is, that's the directory. The file plab.txt is not. These are folders, not files. In fact, when we do that part again, just to show you, we did not go look at the files in the list. If I go to list it now, you'll see plab.txt. And I'll remove it again. Okay, that's all for this assignment. Hope you had fun in this MindTap activity. Let me know if you have any questions.